Hello, everybody, and welcome to the EarthX TV stage. We're here Thursday. We've made it this far, kind of on the down slope here, but we are starting the day with somebody I'm looking forward to spending some time with here, talking about marine sciences, Dr. Debbie Thomas. And you're with Texas A&M?
Yes.
Tell me, what do you do with Texas A&M?
So I've been at Texas A&M University now for 21 years. I started as a faculty member in the Department of Oceanography, where I researched using the sediments that accumulate on the seafloor. I studied the chemical composition of these sediment grains to study ancient climate, particularly periods of Earth's history when climate was warm, as a way for us to learn about the world into which we're headed. So the discipline is called paleoceanography. And funny story, the iPhone autocorrects paleoceanography to pale oceanographer, and I'm neither of those. But maybe it's better now. But so the discipline relies on looking back in time in the geologic record to find intervals of Earth's history when climate was really warm as an analog for understanding the future climate as Earth continues to warm. So I researched and taught on the faculty, and then found myself in the administration helping to lead the mission at Texas A&M. My current role, I'm the founding dean of the College of Marine Sciences and Maritime Studies. This college is based on our Galveston campus, and it's absolutely my dream job, because everything associated with the oceans, from the blue humanities to the social sciences of sustainability to the life and physical sciences. And then we also have business administration and logistics, and the disciplines that train the future officers who operate the ships in support of our entire blue economy. So it's such a cool gig. I love my job. Gotcha. Okay,
I want to take a giant step backwards.
Yep.
You're in love with the ocean, as many of us here are. Tell us, what was that first spark for you in falling in love with the ocean?
Thank you. So I was 10 years old when I decided I wanted to be an oceanographer. And to this day, I still don't even know how I knew that word. And the punchline here is that I was born and raised in Cincinnati, Ohio, like a 10-hour drive from the nearest coast. So, but I had the opportunity in one of my fourth grade classes to pick a topic to research, and I chose oceanography, and fell in love. I decided at that moment in my life I was going to be an oceanographer. Not quite sure what an oceanographer did, and my parents were not quite sure either, and spent the next 8 years trying to talk me out of it. But along the way, I also had the chance to take an earth science class in 8th grade, which is also pretty rare in Cincinnati back in those days. I'm not going to tell you when those days were, by the way. But I realized, as I got closer in time to thinking about picking colleges, I definitely wanted to find a university where I could major in oceanography or marine science, and also pursue my other dream of being a Division I college athlete. And it turns out the intersection of those two, where I could make the team as a tennis player and also study marine sciences, was very small. But I remembered from my earth science class that I could study earth sciences and geological sciences, still kindle my passion for the oceans, and then go on to graduate school in marine sciences. And so that's kind of the path I laid out. It was, yeah.
Very
and so
good.
when I started at Texas A&M, it literally was a dream come true, because I was an oceanographer.
So you picked it early on. Okay.
Yeah.
So you're kind of landlocked, and you decide to be an oceanographer.
Yeah.
Do you remember the first time you actually locked eyes with the ocean?
Oh, we had taken, so my grandparents had a home in Florida, and so we had taken several trips as a child to the beaches in Florida. So I knew I loved it even before I knew I wanted to pursue my life's passion as a career. So.
Okay, so you, again, growing up, not in the ocean,
Yeah.
but decide to be an oceanographer. Do you remember when you first dropped underwater and went, yeah, this is for me?
I think it was less a moment in the water and more just immersing myself in everything I could. So that year for Christmas, I got a membership to the Cousteau Society, and I literally read everything I could get my hands on, and so thinking about the science and what the different dimensions of marine science really encompass was because I was a total geek. I stayed in my room reading all day. I didn't.
So, okay, for those who don't know, tell us a little bit about what are the marine sciences beyond just, hey, I'm down scuba diving looking at interesting fish and coral, coral growth.
I love that question. The marine sciences are so incredibly diverse because you have to think about everything from the life that's supported by the oceans to the chemistry of the water and everything dissolved in the ocean to the physical processes that move ocean water around, which are intricately linked to the atmosphere. And of course, I found my particular area of specialty, my niche in the marine sciences, at the intersection of geology and ocean science, which is taking all of those components, the motion of the water, the organisms living in the ocean, the chemistry of the water and the biota, and what that looks like in the geologic record as things fall to the seafloor and accumulate over millions of years. So it's.
I want to talk about that.
Yeah.
Before we get there, so oceanography and climate, how do those today come together and put us in the situation we are here? You grew up being an oceanographer, loving the ocean,
Yeah.
but then you find out what's some of the issues going on with it now. How do those two come together? And we'll get to higher education here in just a bit.
Perfect. Well, it's impossible to deconvolve the two. I mean, the oceans are intricately linked to the entire climate system, and the reason why it's incredibly valuable, particularly from a geologic perspective, to think about the oceans as an archive of climate, is because the oceans provide a wonderful average state of the planet at any snapshot in time. Now I'm totally geeking out geology. This is so fun.
Go for it. Be a geek on it.
But it's when you think about the ocean and atmosphere as really the internal component, the planetary component of Earth's climate, the oceans. I mean, each has equal weight in terms of what's driving the system. However, the oceans provide the opportunity to think about a more average state of the planet.
I'm going to ask you something that's a little tiny bit off topic.
Yeah.
And our editors may cut this out, but I'm just personally curious. So I've been researching a bit about how some of the flows of the ocean may be slowing. There's maybe even some research that maybe they're possibly going to reverse. What is that about?
So the movement of the oceans, the circulation of the oceans, the currents, as we think about them, really you can break that into
what's
two
the term for that?
Ocean circulation.
Okay, but
the
gyre.
the thermohaline circulation.
Right. Yes.
So this is
we're
or
geeking out
overturning.
already.
Yeah. Oh yeah. This is, man, we're unpacking some cool parts of my life I haven't gotten to engage in a while. So thank you. So you can think about the movement of ocean water around the planet in two separate systems. The first is the surface ocean currents. Think about the Gulf Stream, the Loop Current, some of the currents that move sand along the beaches. That's the surface ocean circulation that's driven entirely by friction from the wind. Okay, but then below the surface layer, we have the vast majority of the water on the planet, right? Water depths 4,000 to 5,000 meters in most of the deep parts of the ocean basin. And that's the thermohaline circulation. So this is water that sinks in some places of the planet and rises back up in other places. And it's controlled by changes in the density of the water. So now we're really... I
love it.
You took me down this rabbit hole. We're going.
Let's go.
We're going. So there are two ways to affect the density of seawater. One is the temperature. Colder things are denser. The other is by the salinity, the amount of dissolved material in the ocean. So the more dissolved salts, the saltier the water is, the denser it is. Okay, well right now in the current snapshot. As a geologist, I like to think about this current phase as a snapshot of our Earth's history. But right now, the places where water sinks are where water is really cold. And so that's the high latitudes, Arctic region and Antarctic. But at times in Earth's past, when climate was fundamentally different, those regions where water sank or rose back up were very different. And so it's
fascinating.
Yeah.
Well, I know you've done research in sediments. And talk to me a little bit about that. What can we learn from just researching sediments falling to the different zones?
Yeah. So the whole reason I ended up at Texas A&M University as a faculty member, because Texas A&M since 1983 was the host, the operator of a drill ship that was converted from oil and gas exploration to science. And this drill ship literally recovered cylindrical tubes of the layers of sediment on the seafloor from all over the world.
Similar to how they drill for ice cores?
Literally, same thing.
Okay.
And instead of just plowing right through to get to oil and gas, we recovered everything. And so we have an archive of hundreds of thousands of kilometers
tell me
of
about
these
this.
sediment layers. In the ocean basins, as sediment accumulates, you get the oldest stuff on the bottom, and it gets younger and younger with age. And we can use the composition of the sediment grains themselves. These are the shells of organisms that used to live in the surface ocean. These are also grains of dust that blew in from the nearby continents. And so we can use the composition as well as the shells of the organisms themselves to learn a lot about the past environment at the time.
So we're talking about sediment on the bottom.
Yeah.
I'm going to take a little sidestep here, because I always found this fascinating. That sand on the beach is from parrotfish poop, from corals. Is that not true?
In some beaches it is, yeah. So in some beaches, the grains of sand are actually the broken up skeleton of coral. In other places, they're grains of rock that have been weathered and eroded and transported by rivers downstream.
So if you're like laying on a beautiful beach, you could be laying on just coral dust.
Yeah, or if you've ever been on a black sand beach in Hawaii or Tahiti, those are the broken down mineral grains from the volcanic rocks.
Fascinating.
Yeah.
Okay, let's talk higher education. So, you oceanographer, research in sediment. What is it that drives you on just teaching the next generation, getting all these people involved? What do you hope to get out there?
Yeah, there's so many things. I now have this platform leading a College of Marine Sciences and Maritime Studies that enables me to try to reach the kids out there that I was, right? And to engage the public in the understanding that the careers that support all dimensions of marine and coastal and maritime sustainability are incredibly rewarding and and critical to holistic sustainability moving forward. And so I get up, what gets me out of bed every morning is the idea that I can reach kids who don't even know about these careers and don't even understand how important sustainability of the coastal marine and maritime environments are, and that and more importantly, or equally importantly, the parents who don't necessarily know that they're actually rewarding and potentially lucrative careers in these fields. But I also, one of the most important things we can do right now is celebrate and reinforce the value proposition of higher education as mission critical to building a holistically sustainable future, right? It's not, it is about training the next generation of leaders who are passionate about all dimensions of sustainability, but the research and discovery and innovation that's performed at institutions of higher education absolutely makes a difference in improving lives and livelihoods. And I can't think of a more noble mission and a call to really embrace the opportunity to continuously reinforce the value that higher education brings to the nation and the planet.
Fantastic. I've got a few more questions. With all that we're hearing about oceans, and especially at this conference, we're all pretty enlightened on what we're hearing about what's going on with the different oceans. With your students coming up, let's just say the past 5 years, are you seeing like light bulb moments that come on for them, and you're seeing that over and over? That's like something that they didn't know about. That's kind of become a theme.
I think with some, yes, but with others, they're coming already with this passion and this unprecedented access to information that students have today that we simply didn't have when we were kids. But yeah, I mean, I think the realization that they can actually do work that matters, and seeing that, whether it's in policy or pre-regulatory or thinking about how to apply their highly interdisciplinary training and ability to think critically into legal and regulatory and even policy. But also, so many of our students come with a passion for conservation and practicing as scientists.
I'm going to take it a little dark for a second, and then we'll come back to it being light. So back to talking about what we read and hear about with the oceans going on. Again, for an audience that beyond EarthX, and viewers, tell us a little bit about, since you studied sediments, a little bit about what things you would never think you'd be finding on the bottom of the ocean floor. Mariana Trench, deepest part of the planet. What are we finding down there? How are we finding this? What's going on down there?
It's immensely troubling to see the things that humans have created ending up in what should be the most pristine environments on the planet, the most remote. I've been on research vessels in the most remote parts of the Pacific Ocean, and there's still stuff out there. And I think what's even more troubling is...
I'm going to stop you there. What kinds of stuff? People that they have in their house.
Yeah, plastics, bags, toys, buoys. But the plastics problem, I think, is pretty well understood. But until you see it, until you're out in the middle of nowhere, and you're the only ship that you've seen for days, and you can still find things floating, is troubling. And I think that's what we see. What's scarier is what we don't see, the micro and nanoplastics. I have colleagues who actually have discovered nanoplastics in the tissue of the fish we eat.
So we know the microplastics, just most common household products being deeper in the ocean than, the highest mountains are high. They're even deeper than that in the ocean, and they're on the floor. We know about that. With some of the new technologies coming along and the research and your students more than anything, what are some things we can have hope for? Dr. Sylvia Earle, she talks about her hope spots.
Oh, yes. No.
So, but what are take us somewhere good on this. Where can we go from here?
I'm incredibly hopeful because we have so much passion and energy in the students who are seeking us out for professional development. I also have a tremendous hope because there's so many organizations and individuals who are doing amazing work. For example, we just hosted Washed Ashore, the nonprofit that funds the creation of artwork from the plastic debris that washes up on beaches. And the advocacy and awareness that groups like this are spreading, in addition to the role that we play in higher education, gives me a ton of hope.
No, thank you so much.
Thank you.
Thank you for telling us a little bit about what you do and giving us the hope with what you've got going on at Texas A&M, and continue all the great work. Thanks everybody for being here.
Appreciate it.
Thank you so much.